Hello everyone, I'm Saptarshi, and in this video we will discuss the problems from Codeforces Round 805 Division 3. So let's get started. Let's start with problem A, round down the price. The problem says at the store the salespeople want to make the prices round. What is round? A round number is a number which is a perfect power of 10. Say like 10 power 0, 10 power 1, 10 power 2. They're all round numbers, but 20, 110 and 256 are not round numbers because they're not perfect powers of 10. So if an item is worth m bulls, so if an item is worth this m bulls, then the sellers want to change its value to the nearest round number which is not greater than m. So like we have to change this m to a perfect power of 10 but does not exceed m. So they ask you by how many bulls you should decrease the value of items to make it worth exactly 10 power k bulls, like a round number. So an example is also given, say 178, the maximum power of 10 which is less than it is 100. So to make 178 to 100, you need to deduct 78. So your answer will be 78. So you will be given an m and you need to find how much you need to deduct to make it a perfect power of 10. So this is a pretty simple question. For you need to first find the maximum power of 10 which is less than m. So you can keep on multiplying like 1 then 10 then 100 and check like that till it's less than m. Once it exceeds them you stop, so you come back to the previous power of 10. So once you found out the maximum value of maximum power of 10 which is less than m, so less than or equal to m, so then you need to find difference between them. So that would give us the amount of bolts you need to deduct, right, to get the maximum power of 10. So yeah, this is about the explanation of the problem. Let's see the code. Yeah, so this is the code. I'm starting from 1. While this p is less than n, it does not exceed n, I keep on multiplying by 10. Once I exceed, overshoot, then I have to come back, right? So I need to divide by 10 and then I find the difference between them. Yeah, so this is about problem A. So let's move on to problem B. Polycarp writes a string from memory. It says Polycarp has a poor memory. Each day he can remember no more than 3 different letters. Polycarp wants to write a non-empty string of S consisting of lowercase Latin letters taking minimum number of days. In how many days will he be able to do it? So it says say like lollipops, it can 2 days. On the first day he writes LOI, he memorizes these 3 letters and can write till LOLLI, the first 5 characters of the string. And on the second day he memorizes these 3 letters and he can finish off the complete string by writing down the final 4 letters of the string. So this is a purely implementation based question. So let me show you how it works. So lollipops. So you've given the string. So what you do, you iterate the string, and whenever you find a character, you store you store somewhere the characters which are being read. So this first L you store it here, and this can be written in day 1. So O you can write store here and written in, it can also be written in day 1. L is, you can see this already stored, so you don't need to store it again. L you don't need to, you already stored, so you don't need to store it again. I is not stored, but it can be memorized because Polycarp can remember at max 3 letters, so it can be memorized in first itself. So you memorize the I and you write it here. So P, then when you see P is not used here, so you have to memorize P, but there is no Polycarp cannot remember more than 3, so Polycarp cannot write P in the first day itself. So he has to switch to the next day, right? So now here starts day 2. So on when you start a new day, you can forget the previous letters also, so you completely delete all them. So so now day 2 starts. P, he memorizes P and writes P. O, you can memorize O. P is already memorized, so you don't need to write. And S, you can memorize, so and write. So here till here the maximum value which you can went he went to till is 2. So like all these are 1, like all these 5 characters can be written in day 1 and the remaining 4 characters can be written in day 2. So in here we can see Polycarp can write the entire string in 2 days. So this is basically the uh, explanation of the problem, and the implementation of the problem is also pretty similar. There is nothing much about it. So let me show you. Like string, I'm finding on the size of the string. Then I'm just like this memorizing thing. I'm storing it in a set, and this count will be the answer, like number of days. Like Polycarp has to take at least 1 day, so I'm initializing it to 1. Then I'm iterating through the string. So if the current string is already in the set, right, because like this is my set of memorized string characters. If the current character is already in the memorized set, then I don't need to anything continue. If it is not in this memorized set, so if it is not, then I check the size of the memorized set. If the size of the memorized set is 3, then I cannot afford to add another character, so I need to clear the memorized set. Then I need to increase count is the number of days required, so I increase it, and after increasing I just insert this particular character in the set. Or else if it is less than 3, then I can afford to insert this character in the set, so I just insert it. And finally I just print the count, which is the number of days required by Polycarp to write the string. So this is about problem B. Let's move to the next problem. Problem C, train and queries. It says along the railroad there are stations indexed from 1 to 10.9, and express train always travels around the route consists of n stations at indices u1, u2 till un, and the train travels along the route from left to right. It starts at station u1, then stops at u2, then u3, and so on till un, the terminus. It is possible that a train will visit the same station more than once. That is, there may be duplicates around the values u1 to un. So you are given k queries and each containing different integers aj and bj. For each query, we have to determine whether it is possible that I can travel by train and reach from station aj to bj. So there will be like the path travel route of the train which will be given, as in here say is given 371514. So it says that the train first travels to 3, then station 3, then travels to station 7, then station 1, then station 5, then station 1, then station 4. So we will be given queries from aj, some aj to bj, and we need to determine whether I can move from AJ, like train moves from left to right, like in this manner, right? So I need to find if I can move from station number AJ to station number BJ in this route. So let's say 3 and 5, A is 3 and B is 5. So it sees can be seen that I can sit here at station number 3 and move along this way, and I can find 5, right? So this is fine. 1 and 7. If A is 1, I sit here, but if I move right, I cannot find 7 because 7 is to the left. Similarly, if I sit here at 1, start at here, I move along this way, but I cannot find 7 and the route because 7 is already crossed. Like there is no 7 after 1. So and say A3 and B10, it's obviously no, because 10 is not a station at all in this route. So what we for each AI A and B, Basically, actually we need to find that if there is an occurrence of B after A in this array. So say if A is 3 and B is 5, I just need to find out that if, so I can find I can find 5 after 3 here. So in this case the query, the answer is yes, but for 7 and 1, for any of the one here I cannot find a 7 after this one, so the answer for this query will be no. So if you like, for each query, for every AI you find, for every A you keep on finding, like iterate through the array and find if you find a B or not, then it will be obviously give you TLE, time limit exceeded, because the complexity of that algorithm will be order n square. So but n is here like 2 10 power 5, and number of queries also 2 10 power 5, so like it will be like exceeding. So how to do it in like less time complexity? So for each of the elements here, you will find store the maximum first occurrence and the last occurrence of that particular element. What do I mean by here? That is for 3, what the first occurrence is 1, the last occurrence is 1 at index. The index for 7, the first occurrence is 2, the last occurrence is also 2. So for 1, the first occurrence is at index 3, but the last occurrence is at index 5. For 5, the first occurrence is 4 and last occurrence is also index 4. For 4, the first and the last occurrence are both at index 6. So in this way we have computed the first and the last occurrences of each of the elements in the array. How you can store it? Like in for coding part, you can use a map to store for each element. So now once you have computed this, for each query, say I have given 3 and 5, you need to move from 3 to 5, right? So you need to see if some like a 3 will be there before 5. So if there is a 5 after 3, which means the first occurrence of 5, like there is an occurrence of 5 after 3. So when can 3 and 5, like when can 5 not come after 3 at all? Like after 3, 5 doesn't come at all. When it happens when the last occurrence of 5, see this is the last occurrence of 5, this occurs before the first occurrence of 3. So this is the first occurrence of 3 and this is the last occurrence of 5. Say if the last occurrence of 5 is before the first occurrence of 3, then if this is the first occurrence of 3, all the 3's will be after this only. And if since it is the last occurrence of 5, all the 5's will be before this only. Right? So in this case, I can never move from 3 to 5. But if say the last occurrence of 5 is after first occurrence of 3. If the last occurrence of 5 is after the first occurrence of 3, I don't need to worry, because like say the last occurrence of 5 is j, the first occurrence of 3 is I. I already said the last occurrence of 5 is after first occurrence of j. That means j is greater than I. Since j is greater than I can pick the ith, this in 3 at index I and this 5 at index j. I can move from I to j, because I is less than j. I move from I to j in the root. I can find the 5 after 3. So this is pretty simple. But if the last occurrence of 5 is before the first occurrence of 3, so in that case, I just showed you here, no way we can move get 2 for 3 and then move right to find the 5. That cannot happen. So this was all about the explanation. Just in the coding part, you need to store this using a map The most convenient way would be to use a map which was stored the starting and the ending index of that particular element. So let's move to the code of this. So I've used a map. Here I've instead of storing the first and the last indices, I've instead stored all the indices of the array, and I've comparing the first occurrence of index and the last occurrence, like last index. So after that, declare the matrix and declare the map, and after array A, I'm taking the input and I'm storing the index of that particular element. Like I'm mapping the value of the array to that index. So this is for each query, and for each query I'm inputting the u and v. This is the base case, like trivial case. If like for this case, I'm checking for this case, like if either of a and b does not even occur in the array. If it does not even occur in the array, then for obvious reasons the answer will be no. But otherwise, I'm checking if the end index, last occurrence of the second array, like second element b, its last occurrence is less than the first occurrence of a, first occurrence of u here. If it is less than the first occurrence of u, then I'm printing no. This case I'm talking of. This case I'm talking of. This case I'm implementing here. MV of back is less than MU of front, then print no, or else print yes. So this was about the code for problem C. Let's move to problem D, not a cheap string. It says let S be a string of lowercase Latin letters. Its price is the sum of indices of letters. An integer between 1 and 26 that are included in it. For example, the price of string ABC is 1 plus 2 plus 3 plus 1, which is 7. The string W and integer P are given. You have to remove some letters from W so that its price becomes less than or equal to P, and print the resulting string. Note that resulting string can be empty. If you can delete arbitrary letters, then do not have to go in a row. If the price of the given string W is less than or equal to P, already less than or equal to P, then nothing needs to be deleted and W must be the output. Note when you delete a letter from W, the order of the remaining letters is preserved. For example, if you delete the letter E from string test, you get TST. So, like basically what I need, let me show you with an example. Say A, B, C, A. So what this is, the price of this is 7 and the value of P given is 2. So 7 is greater than 2, right? 7 is greater than 2. So I need to remove some characters such that the price becomes less than 2. Say I remove C and B. I remove 2 characters. The resulting string is AA. This price of AA is what? 2. And 2 is less than or equal to 2. Perfect. So you can check that you cannot remove one character and make the sum of make the price of the string less than or equal to 2. You have to at least remove 2 characters, and I showed you an example. If you remove B and C, the price becomes less than or equal to 2. So you need to remove minimum number of characters, right? So supposedly given you have to remove one character, and like the price of the string is already more than P, so you have to make it less than or equal to P, the price, and you need to remove a character for that, some characters from that. Like what is the possible most likable character to be chosen, so that you can minimize the price of the string to like make it less than or equal to P by removing minimum number of characters. You should obviously you should, like in greedy purposes, you should remove the character which has a largest maximum value, maximum index. Say here in this string, the character with maximum value is C. The C has value of 3, right? So if you remove C, the price decreases by 3. But if you remove A, the price only decreases by 1. So it's obvious that for greedy purposes, you should remove the character with maximum value. So and keep on, like, basically the algorithm is keep on removing the character of maximum value until and unless the price of the string remaining string becomes less than equal to p. So how to go about implementing it? So what you do is you maintain a frequency array of the characters. So the first element will store frequency of A, second will store frequency of B, third will store frequency C, fourth for D, and so on till Z, right? So for ABCA, the frequency table will array will be like A will be 1, no, A will be 2, B will be 1, C will be 1, D, E, F all 0 till Z 0. So this array you can easily populate using by iterating through the string. So once you compute this array, so what you can do is your current sum is 7, your required sum is less than equal to 2. So you check the maximum value of character maximum value z. It is already like it is 0, so you cannot remove anything from here. So you keep on moving from right to left until and unless you hit an element with non-zero frequency. The first time you hit a non-zero frequency, just see here 1. So you need to decide whether you need to remove all the C's or only some of the C's. So there are two cases regarding that. So let's forget 7 and 2. Let's say you have 4 C's. Let's say the frequency of C is 4. There are 4 C's. Each of the C's will be a value of 3, right? So the total value is what, 12. 3 times 4 is 12. There are 4 C's. The frequency of C is 4, and each of the C's value 3. Say suppose you have to currently your sum is 15, and you are required to make the sum less than equal to 2. So what happens, like the total value is 12, right? So if you remove all the C's, how much your sum will price will decrease? Your price will decrease by 12, and still the price of your string will be 3, which is greater than equal to 2. This is greater than 2, right? This is greater than 2. This won't work. So like if after removing all still the price is more than 2, then you have to remove all the C's and then move to the next maximum character, which is B. You need to check for B. But what if your current sum was 15 and you are asked to make P for only like say 10? Then you do not need to remove all the C's. You need to remove, you can see that only after removing 2 C's, by remove 2 C's, the price of the string will reduce by 6. 3 plus 3, which is 6. It will reduce by 6 and the price will be 9, and 9 is less than 10. 9 is less than equal to 10, so it's fine. So once, like if your current sum is S and the required price is P, and the value of the character which you're correctly looking at is V, then mathematically speaking, the number of characters which you need to remove is S minus P divided by V, the floor of it. You need to remove this much at least. So like if, like first case I explained was if the difference is still more than the total value of this particular character, then you have to remove all of the character frequencies, like all of the characters from that particular character, all of the frequency you have to remove. If not, then you have to only remove some of the characters. And how many characters you need to remove? This current sum minus the required price upon V, the value, like the index value of the particular character, the floor of seal of it. And once you remove this many characters, you are guaranteed that the sum will become less than equal to P. you don't need to check for anything further left. You're done making the some price of the string less than equal to p. So this was the explanation of the problem D. Let's move to the code of this problem. So this is the code. I am declaring the frequency array and I am populating the frequency array. Then I am calculating the sum of the values of the characters of the array. If sum is already less than p, then I don't need to remove anything. I can simply print that original string itself. But if the sum is greater than p, I am iterating from the rightmost end, right? I am iterating from the right. If the current sum is less than p, then break. This is purely implementation. Like if even after removing all the frequency of that particular character, I am still it is not sufficing the difference, then I have to remove all of them and make the frequency 0. Or else if I only need to remove some of them, then how many do I need to remove? The seal of it. I'm just calculating the seal of this, the difference divided by the value with everything like this. That's implementation. So but I just don't need to make that. I need to print the string also. How to print the string? Now I am like as I'm iterating to this frequency array, I'm also updating the frequency array. Like if I'm removing everything, I'm making this 0. If I'm removing some of them, say like I need C was 4, frequency of C was 4, I only remove 2 of them, then my new frequency will become 2. So my updated frequency array will be something like 2 1 2 1, say 4 3, something like this. A for A, B, C, D, E and all. Now I will move iterate to the original array. I will iterate to the original array, and for each character's frequency, like remaining frequency, will be either equal to or less than equal to the frequency in the original string, right? Because I have removed some of the characters, so the frequency of each character will be either less or equal to, right? So I just iterate to the frequency array, like I iterate to the string, and for each character I just check if it is the frequency, there is still some characters need to be used, then I can use it up, and decrement after using it up, I decrement the frequency by 1. Say I print A, then I reduce it by 1, and again I print A, I reduce it to 0. Say in the original string I get A, but the frequency of A is 0 now. That means like I cannot print that A again because the frequency is 0. That means actually I have removed that A somewhere in the, like in deletion. I have deleted that A somewhere in some operation. So in that way you can just check if there's still some frequency of that character remaining, then only you will print, otherwise you won't print. So that's what I did here. For I equals 0, if the frequency is still greater than, then I'm printing the character and decrementing the frequency. Else if frequency is 0, then I'm not printing that character. Yeah, so this was about problem D, not a cheap string. Let's move to problem E, split into two sets. It says Polycarp had recently given a set of n dominoes. Each domino consists of two integers from 1 to n. It says can it divide all the dominoes into two sets such that the numbers on the dominoes in each set are different. Each domino must go to exactly one of the sets. I am taking this example, say 1 4, where then what are the 1 3, 3 2 and 4 2, 3 2 and 4 2. I can divide the dominoes in this way: 1 4, 1 3, 3 2 and 4 2. I can divide it in these two sets. These are the 4 dominoes. Now in each set, this set, you can see all the numbers are distinct. In each set, this set also, I can see all the numbers are distinct. I just need to find, given n dominoes to me, if I can divide these dominoes into two sets such that each of them, all the values on each set are distinct, and each domino has to go to exactly one of the two sets. So this is basically a question on graph. It, uh, so first of all, first what you need to observe is that any particular value cannot occur more than 3 times. Like say here and there I can choose another, say another domino 1 5. So 1 4, see 1 4 comes here, 1 3 has to go to another set because of the 1, because if I keep 1 3 here, this 1 becomes common, so I cannot put in this set, so I have to keep 1 3 in the second set. Now forget about these two. Now if I want to place this 1 5, where will I place 1 5? I cannot place here because there is already 1 here, so I cannot place over here also because there is a 1 here. So the maximum frequency of any element cannot exceed 2. So like there cannot be more than 2 occurrences of any number here. So since there are 3 ones, it's not possible. So just first of all, one trivial case you need to check is that if the frequency of any number is more than 2. If it is more than 2, then you cannot separate them into two sets at all. So but if the frequency of all the numbers is less than equal to 2, then you may or may not. So let's see how you can. So in that case, what I can do is for each of the dominoes, what I can do, say this is 1 4. I will connect them by an edge of red color. Okay, 1 3. So 1 is already here. I need to connect 3. Here comes 3, and we'll connect 3 by blue edge. So basically what I am doing is for each color, for each node, I am connecting it to the neighboring, like for each domino will be consist of some two values u v, right? So I am connecting u to v by an edge, and say there is another domino of u w, then I am connecting u to w. I will connect u to w but with a different color. I will connect them by a different color. So this u will have its neighbors connected by edges of different colors. No two edges from the same node will be of the same color, right? I'll making something like this. I'm creating a graph like this. Now say 3 2. 3 I am connecting with 2. I have to color it with red. So I have to color it by red because there's already a blue edge between 1 and 3, and so two blue edges cannot be there. Now 4 2 I can connect it by I can connect it by a blue edge. So in this way I am able to connect I am able to create a graph with edges of alternating colors. So this basically becomes a bipartite graph. So basically need to check whether a graph is bipartite or not by how do I create the graph? I create the graph by connecting an edge between the numbers present on a domino. So what is how do I how to get the intuition bipartite? How does being bipartite guarantee that I can separate it? So it's simple. Say if what does bipartite there is a property bipartite which says that a graph is bipartite if and only if there is an a cycle of even length. There is no cycle of odd length. I'm sorry. A graph is bipartite if and only if there is no cycle of odd length. So what happens if there is a cycle of odd length, say A, B, C, D, E. There is a cycle, right, of length 5. This is A. So these will be of alternate colors, right? I am coloring with alternate colors. So this will be red, this will be red. I can see that this will be of two colors. Like there has to be two consecutive edges of the same color if there is an odd cycle. So if these two consecutive colors of the same cycle, same color, and that means they have to be in the same set. What do these colors actually represent? These colors represent, like this blue color represents that the nodes which are connected by this edge will be present in a particular set. This will be say second in the second set 2 4, and this 1 3 which is colored by blue will also be in the same set 1 3, and this red, the edges which connected by red, the nodes which are connected by these edges will be present in the same set 3 2. So do you understand like this? Red edges will be in the same set, blue edges, the nodes connecting them will be in the same set. So if I have these two blue edges, that means this node, this particular domino and this particular domino will be in the same set. So EA and ED will be in the same set. But this is not allowed because of the same E, two E's in this set. This will be not allowed. So if this is an odd cycle, I cannot make edges of alternate colors. If I cannot make edges of alternate colors, that means two consecutive edges will be of the same color. That means they will be in the same set, and if they're in the same set, like I cannot make it. And if there is an odd cycle, that means the graph is not bipartite. So if there is even cycle, like if there is no odd cycle, that means the graph is bipartite. If there is an odd cycle, that the graph is not bipartite. So basically you need, for these dominoes, you have to construct a graph by connecting edges between the values of each dominoes, and just to check if that graph form is bipartite or not. That's the basic idea of the problem. So let's move to the code. So this is my code. I am just taking the adjacency, I'm like computing the adjacency matrix of here. This is the trivial case. I'm saying that if the frequency, like if there are 3 edges coming out from a node, that means it's not possible because it has 3 occurrences. That particular node has 3 occurrences. So, or if the dominoes, like the number on the dominoes, both the numbers on the dominoes are the same value, like 1 1. So if it is 1 1, item 1, domino 2 2 or 3 3, then also it's not possible, right? So in those cases, I am just making it false, and if OK is false, then I'm printing no. If OK is true, then I am checking for bipartiteness of the graph, and for bipartiteness, if there is an odd cycle, I'm printing no, or else printing yes. Let's move this odd cycle function. This is a standard problem, like how to calculate, figure out whether a graph is bipartite or not. It's a pretty standard problem. You can find it out in internet also. I'm just basically doing a breadth first search over here and checking if, and like marking some colors on the vertices, and I'm just checking if I move back to a visited node, I'm just checking if that visited node's color is same as the current color. So if the visited, like adjacent node, is of the same color as the current node, so that means 2 nodes are the same color, that means they have to be they cannot be bipartite. So that's the basic implementation of this code question. This is a pretty standard problem. Checking by button is, you can find it out in net also. Yeah. Let's move on to problem F. Equate multisets. It says multiset is a set of numbers in which there can be equal elements and the order of numbers does not matter. Two multisets are equal when each value occurs with the same number of times. For example, multisets 2 to 4 to 4 to equal, but the multisets 1 to 2 and 1 1 2 not. You are given two multisets A B, consider n integers, and single operation. You can pick any element of B and it can be doubled or halved. In other words, you have two following operations are available: either multiply x by into 2 or replace x by 2, rounding down. Note that you cannot change the elements of the A multiset. Now you have to find that if you can make the multiset B equal to the multiset A in some arbitrary number of operations. An example is also given to illustrate the same. So let's make some observation. There are some key observations regarding this question. Let's do. When I let's think of in binary. Say I have 101. This is 5. What do I mean when I multiply x by 2? When I multiply x by 2, it becomes 10. And what is the binary of 10? Binary of 10 is 1010. So when I multiply x by 2, x to 2x, the binary of x, whatever the binary of x, and a 0 will be appended to the end of x, that will become 2x. Say this is 101, appending a 0 to the end of 101 will become 1010, which is nothing but twice that number. So multiplying means appending a 0 to the right. What does divide mean? 5 is 101. 5 divided by 2, round down, is 2, which is 10. So division of x, it means right shift. Right shift means removing the rightmost bit of the number. This, if you remove, the remaining number will be x by 2, round down. Say you have 6, which is 110. Removing the rightmost bit will lead you to remain with 1 1, and 1 1 is nothing but 3. 1 1 base 2 is nothing but 3, which is 6 by 2. So multiplying a number means adding a 0 to the right, and divide by 2 means right shifting the binary, that means removing the rightmost bit. So once you understand this, let's move on to the next observation, which is, say I have a binary x, like x in something in binary, which is followed by, say, 2 zeros, some number of zeros, say 2. I have another binary y, followed by some number of zeros. So if I can convert this binary to this binary, this implies by I can convert y to x. This is my observation. This is my claim. So x and y are not numbers. X and y are some binary. Like x can be something like 1 0 1 0 0 1. So like x followed by these 2 zeros, and this y is say 1 1 followed by 1 0. So if I can turn this y0 to x00, that means I can turn y to x. Like basically what I mean to say is that trailing 0 does not matter at all. So if I can turn y followed by some number zeros to x, some followed by some number zeros, implies by I can transform y to x. How? So say I can turn y to x. So what I do, from y to 0 I divide by 2. I divide by 2 to get y. because division means removing the rightmost bit. I divide by 2 to get y. Then I already assumed that I can convert y to x. I convert y to x, and from x I multiplied by 2 times to get x00. So in this way I can convert y to 0 to x00 by via this. So I can say that like the key observation is that trailing zeros does not matter. So here say like 2, 4, 5, 24. So what it will be, like 2 is in binary is what? 1 0. 4 in binary is 1 0 0. 5 in binary is 1 0 1. 24 in binary is 1 1 0 0 0. So what I mean is that trailing 0 does not matter here. I can remove them. Because if I can convert some number here in B to 1 0, I can convert into 1 also. I can convert into 1 also. Yeah, like I can convert it to 1 and then multiply it by 0. Or if I can convert to 1 0, I can divide by 2 to get 1. Simple as that. So trailing zeros here does not matter. Similarly in B also trailing zeros in binary does not matter at all. So first of all what I will do, I will divide each and every element, keep on dividing each and element by 2 such that there are no trailing zeros. I will keep on dividing by 2 such that the resulting is an odd number. Like the last bit will be 1. So I will remove all these. So all the trailing zeros I will remove. So now it becomes 1 1 1 0 1 and 1 1. So and in B also, B is what? 1 4 6 11. So 1 4 is what? 1 0 0. 6 is what? 1 1 0. 11 is what? 1 0 1 1, right? Yeah. I will remove all the trailing zeros. So I remain now left with this modified array. Now I need to convert this B to A, right? This is my modified A, this is my modified B. I need to convert this modified B to modified A. What I can do now, one other observation is that now I don't need to multiply anything in B. My multiplication operation here is now completely redundant now, because multiplying by 2 will lead me with zeros, and I cannot get any number with zeros here, right? So I don't need at all. So I need to see that I can convert from a number to another number only if and only if this number is a prefix of this number. Why prefix? Because since I just now said that multiplication is redundant, I only need to divide. And what happens when I divide a number? Say 1011. If I divide by 2, I am basically removing the rightmost bit, right? So now I am remaining with 101. 101 is available in A, so I am successfully got an element in A. So for each of this element in A, I need to check if there exists an element in B which has this particular element as a prefix of it. So 101 is a prefix of 1011. So I can get 101 from 1011 after certain number of operations. Like I need to remove some bits from there, and removing bits from the right basically mathematically means dividing that number by 2. So how to do that? How to like efficiently check that? I can sort these two arrays. I will like start off with finding the largest number. So I will sort this array A and check with the last two elements. I am keep on checking if this B can be like converted to A by keep on removing repeatedly removing the bits from the right. I can check if it can be converted to A. If yes, then fine. If not, then not. So I can turn next or move on to the next. If I can convert, then I will remove both of them. Then like I am done with this mapping. I can convert this element to this element. Now I need to check with the remaining these three elements. If I cannot, then like if somehow when the answer will be no. Answer will be no if like say it is like 1011, the element in A is 1011 and the largest element in B is 10 111 because no trailing zeros, so yeah 11. So like A is already bigger than B, so I cannot remove bits from B to get A. So in this case the answer will be no. In other case I can keep on removing bits from B to check if it can match with the element of A. And it will not lead to any time complexity because uh, the elements are till 10 power 9. So 10 power 9 is just about 25 30 at max 30 bits. So 30 bits in order of 30 like won't matter much. So this is about the explanation of the problem. Let me show you the implementation of the problem. So I'm inputting the element A, and while it is still divisible by 2, keep on dividing by 2. So I'm just removing the trailing zeros. Similarly for B also I am removing the trailing zeros, and I'm storing B in a priority queue, and I'm storing A in a vector, and I'm sorting all the elements of the vector. Now why I'm using priority queue I'm just explaining in a minute. While like priority queue is not empty, what I'm doing is I'm picking the maximum element from B and maximum element of A. If B is equals to A, if B equals to A, then I'm removing both the elements from A and B. I'm done with it, then fine, move on to the remaining part. But if the element in A is greater than element of B, then I'm printing no. I'm checking this case. If the largest element of A is greater than the largest element of B, then I cannot make A with any of the elements of B, right? So that means answer will be no. Or else if it is less, if element of A is less than element of B, then there's a possibility I can make A from B. I just divide it by B by 2, element of B by 2, that means removing the last element of B, and I push it back into the priority queue, and I keep on continuing like that. And once it becomes empty, priority queue becomes empty, that means I have successfully removed made all the elements of B to elements of A, and I'm printing yes. So this was about problem F. Thank you for watching.